Yeah, good morning. I am Mark Hoffman from Data in Motion, and today I want to talk about modeling for smart cities and which role OSGi can play in that area. And yeah, myself, I am the CTO of Data in Motion, and our company works with OSGi for many, many years, and the same applies to the whole modeling topic. And we have a lot of projects where we combine both technologies together, and I will show you some examples of that. But at first, I want to take a look into a smart city. What is the status quo of an ordinary city? We have many existing inventory systems in such a city. We have lots of departments, each with own software, with own processes, own infrastructures. And it might be possible that we have, for the same problem, we have many solutions, many providers, many software systems that solve that when it comes, for instance, to sensors in the city or traffic light controllers or something like that. And one issue is most of the times that the different systems are not interoperable per se. They might work together, but most of the times they do not. On the other hand, there are also a lot of regulations that influence the processes in such a city. This is typical for governmental processes. And in addition to that, when we talk about standards, maybe in software, there are also a lot of standards, different standards for different topics and in different states of activities. And you have to know that most of the departments have their own context. They usually act a little bit like an island in the whole governmental structure. And they look to a certain problem from their own perspective, from their own focus. And how can modeling help in that way? So modeling itself, it's a methodology to create a common sense, a common language for organization. And it's the main task is to increase the interoperability of all these departments and participating parties. And most of the people think, when we talk about modeling, they think about UML. This is not that wrong. What we don't talk that much about technical aspects. It's more than an aspect of creating something, an own language we speak as a department, and technical aspects are an addition for us IT freaks. It's in the end a process to understand their own processes, their own entities, their own assets. Modeling can also help to look to the same thing from different perspectives. So you can create additional models that are just linked to a certain thing or something else. And in addition to that, we always have documentation, to UML diagrams, it's some kind of documentation. But it's not that model. A diagram is not the model. So what does a city make smart? It's exactly the point. The city has to understand what assets they already have and what values these assets have. And as I mentioned, many departments have many assets. Maybe they look to the same assets from different perspectives. And they should increase the interoperability between their own departments. The department should work together. Some department collects data, the other one needs this data. And there should be a way to exchange these information. And yeah, one important point is many people think then that there's a one-size-fits-all solution for certain problems. Usually, this is not true. But modeling can create a common language, a common foundation for this whole challenge. So what means that for a city? Modeling is about defining entities and relation to other entities. Maybe you have a tree, or a building, or an area, or a trash can. And you can inherit from entities. Maybe you have a special trash can for paper, or for glass, or something like that. And you can also model processes where these entities are involved. Empty and trash can, for instance. And from a technical point of view, you can create, for instance, interpreters that execute such processes from models. You can also transform entities from one to another entity with a similar structure. Or you can create text. Usually we say model-to-text transformation, but we IT guys know it as code generation. But you can also generate a documentation. You can generate a plant UML diagram description, something like that. In the end, can everything be a model? In a smart city, for instance, some examples for assets. These can be buildings, intersections, I mentioned trash cans, or a driver license renewal process. And we can layer the different perspectives of an asset. For instance, for a building, there's an electric plan model, a model for evacuation plan, ordinary construction plan. And all these plans talk about the same building. Same applies to maybe an elevator maintenance plan, an elevator within that building. So I can have different models that talk about the same asset in BASIC, but each from its own perspective, with its own attributes, with its own definitions, and maybe its own processes. We can also model sensors, sensor values. Sensor itself is a static information. It's located at this position. This has this name and maybe this endpoint. And sensor values can be linked to that static model and then contain maybe values or timestamps, whatever. Usually in a smart city, we use it for ETL processes. So we just load data, transform data from databases, from existing systems. We want to analyze these data in a city, creating maybe open data portals and publish these some certain demographic information to the people. On the other hand, maybe I want to analyze my data regarding GDPR-related information. Yeah, and in addition to that, for transparency reasons, I want to audit my data or audit data transformations when I change information, especially when it comes to GDPR-related information. So, and I can also create documentation. That means when we see the whole thing and start modeling in a smart city, we have a lot of models, and so we have to deal with modularity. We have different models with different purposes, and we have some kind of interfaces where these models are connected. And these connections are well defined, these links. Yeah, and we have in a smart city infrastructure, we have distributed components. And each of these components may use such a model, such a schema for a database or maybe a sensor from Sentinel, whatever. And it means in a smart city, a model can come and go every time. I think there's no static way to say, okay, I launch a system and can only handle this one model. So I think a city itself is a dynamic system, and so we have to deal with these changes for modeling. And yeah, the same applies to model changes. So you can create updates, maybe correct some typos or data type issues, and provide new versions of models in this infrastructure, and we have to deal with that. In the end, there's a need for a central registry that knows all models in such a smart city with different contexts. And sure, we need authentication, authorization. I don't mention that. This is true for every system in a smart city, but the same applies then for such registries. No one should be able to see all models. You want to restrict some visibilities for sure. Which role does OSGi play? At first, there's an Eclipse Modeling Project, EMF. Maybe someone of you knows that. Who knows EMF? So it's one of the top-level projects at Eclipse, at Merck's framework. And it has a very large ecosystem with components around it, from code generation, transformation, DSL creation, modeling UIs, web-based modeling UIs, and so on. And it's one of the oldest Eclipse projects. In addition to that, we have Gecko EMF, which is a data in motion open source project. And we have created some extensions to deal with EMF in a pure OSGi environment. A few years ago, I already had a talk about it, our base components. EMF itself deals with the Eclipse way of registering models. It uses the extension registry, the non-OSGi way. And we decided to create an extension from our perspective. With our software, we have more possibilities. In addition to that, the Gecko EMF framework also contains a D and serialization framework. We call it the Gecko codec, which has the possibility to serialize EMF models in whatever you like and deserialize it from whatever you like in the same way. Yeah, on top of the codec, we have the persistence layer, which is just implementation for serialization. We currently have a MongoDB and Lucene implementation. We're working on JPA as well. And our Gecko EMF project will hopefully move to the Eclipse Foundation. We just have a proposal public for the Eclipse Gecko project. Our Gecko EMF OSGi sits on top of an ordinary EMF. We have a model registry that already exists in EMF. We have it as a whiteboard. If you want to register a model, then you just register services. In that case, these are model packages. We also have an extender pattern for detecting EMF models in bundles. And the usage of EMF is based on so-called resources where you can load resources, save resources, and get your instances out of it. And this handling of resources is also service-based. So you can inject a resource factory, create resources, and load and save. Everything is almost everything is configurable. We have one basic registry for models, but we can have multiple ones. This is not possible in the default EMF. And we have the possibility, for instance, to configure dynamic model handling, so loading a model file from elsewhere and registering it in our system. And in addition to that, EMF already contains a code generation component. We have an own code generation component. We extended the default one to generate the OSGi related code. That means we create some components and conditions. Currently, we work on a distributed model registry. We call it the Model Atlas. And we also optimize the serialization, deserialization, and the persistence. I want to talk about the Model Atlas because it's an important thing for smart cities. The Model Atlas is a more HTTP-based EMF model registry. You can have model isolation. You can create as many registry instances as you like. Each instance gets an URI in an endpoint. And you can have model isolation. So that means you can only see the model that are in that specific registry, and you can configure each registry in a way that it only contains certain models you want to have in. In addition to that, we talked about the dynamics. When you want to register a new model or model updates, we have a pluggable and extensible model analysis extension, where it's possible, for instance, to verify the model for certain consistency or validation or something like that. We also have pluggable model output formats. Usually we use REST for the endpoints, and the default output format for such a model description is XMI, which is an XML dialect. But we can also provide outputs for XSD or JSON schema. Or we can create documentation, diagram images, plant UML, or maybe a presentation CSV-based or ODS-based, whatever. The Model Atlas is also an extension for DCAT and RDF support, which makes it possible, especially in smart cities, to connect open data registries, for instance, or open data portals, where you can then register your model in an ordinary open data catalog. And we have client adapters for model discovery for Java, but we also work on implementations for TypeScript and Python as well. So there's something called PyCore, which is a Python implementation of eCore, and there's also type, I don't know the name. Marcus knows the name, but he's not here. So this is how our Model Atlas looks like a diagram. It's quite large. We have a schema store. You can persist your model definitions in databases in a file system, or maybe in a different Model Atlas, or via HTTP, somewhere at GitHub, whatever you like. And you can have multiple schema registries that are all configurable. And each registry gets an own endpoint, and then it gets own output formats. Everything is configurable. We're currently working on an UI where you can administrate everything and also create some models. But because there are already some model editors out there, we have to see how far we want to go with that. Yeah, on the other side, We have then third-party applications, and the third-party applications are those who just want to consume these models. They want to load some JSON files that are of that schema from Model A, for instance. So they need the schema information in a whole distributed environment. And we have lots of third-party applications or components that want to use such models. And this is what a model atlas is for. It's, so to say, it's a single point of information about models in a distributed infrastructure. In addition to that, let's go back, you can see we have analysis possibilities or mapping possibilities, and especially for analyzing tooling, we created an own component. It's also OSGi based, and it uses our model atlas, for instance, and it uses the OSGi dynamics. Because every model is a service, we have all this dynamics from OSGi. We get informed about every service change, for instance, and then we can trigger model analysis, for instance. And this analysis tooling creates reports, depending on what you want to analyze. Currently, we support GDPR dictionaries and medical dictionaries, and we just analyze these models for sensitive GDPR and medical information, and create a report which attributes and which class may contain sensible information in the schema. And with that, we get an information about special attributes, and we can deal with these attributes. For instance, we can create depending on the type of an attribute, we can create a anonymization configuration for an anonymization tool. Currently, we see it as a decision support system, decision support system for GDPR offices in smart cities, for instance. And we have a remote service communication with a machine learning component, which is Python-based. And we have two perspectives in this analyzing tool. We have the model analyzer. Each time a new model comes into the model atlas and will be published, we can analyze it regarding our dictionaries, GDPR, medical, and also this is pluggable. You can create your own dictionaries for your own context. And then you can run all these checks for your model in a smart city. On the other hand, for sure, from the first report we know which attributes are sensitive. That's fine for us. But if we have instances, if we get the real data out of a database from a certain schema, then we have all the other fields, maybe a node or a documentation field, that may also contain sensible information. And this is a second step that we provide is checking instances of a certain model if they contain sensitive information in all the attributes that are not marked in the report before. And the thing is, out of that, we can get a next report. You can also do quality checks and verify if your data, if your mandatory fields are in a database are set, something like that. In our case, we create a report from data sets that contain sensitive information. Everything we do is based on natural language processing algorithm, and with the results that come out of the report, we have the possibility to retrain this algorithm. So it's not just a black box. Yeah, and beside the model atlas and our privacy tooling, there are a lot of other components that use this EMF and OSGi combination. For instance, this Eclipse Sensinect can be used with EMF models as well. You can create an adapter to use exactly EMF within Sensinect, and we want to connect Sensinect directly to the model atlas, so that we don't have to provide all the model information, the schema information into the Sensinect system. We just provide it to the model atlas. Sensinect resolves all the schemas to our model atlas. The same applies to Eclipse Danse, which is a data analysis tool, and it internally also uses EMF, and it's also based on OSGi. Yeah, then we have our Gecko persistence layer, which currently supports Lucene serialization, so indexing and searching, and also writing in MongoDB and reading out of MongoDBs with a certain query API. In addition to that, we have our QVT. QVT is a UML standardized language for model-to-model transformation. You can not only map things from one attribute to another, you can also create structural changes in your models. Maybe you have a flat person that contains a telephone number, and then you want to transform that in a structured person that has a contact class with a value field, and you can also automatically create such relations. And this is what QVT is for. QVT itself is based on OCL, the object constraint language, which is something like XPath, but also specified in UML specified part. And in addition to that, we have a different third component, the Gecko notary system. We call it the digital notary system. And this is a distributed OSGi component. You can hook into other third-party applications, and you can audit certain activities. Maybe you have a transformation of GDPR-related data, you have to document that, and you can use that system just to hook in and say, okay, this is my source model, this is my destination model. I did something like a transformation with QVT using that mapping file, and then everything goes into the auditing system and is then logged in a standard way. Out of these log information, you can create documentation for GDPR, for instance, or transparency reports for certain applications and components. So, when we talk about a model-based urban data platform, then we will see that our model atlas is a single point of contact when you want to use a model, when you need model information, schema information. Model changes can be reflected in so-called DCAT registries, which is a necessity for publishing open data information in the European Union. And the same applies to publishing information into data space registry. We talk about Gaia-X or international data space systems. They also talk with the DCAT models. Yeah, in addition to that, in an urban data platform, you need event-based information. You need a data broker like Sensinect. It should also use the models and contact the model atlas. I described it before. And you also need some systems that can analyze your information, to go through all the systems, and also to verify your models. This is in the end, yes, we need some persistence layer. We have existing databases, and we need to load existing data, and maybe even store new data in such a system. And yeah, we need data analysis. Eclipse Dancer can do that. And yeah, maybe someone wants to use auditing processing in the overall system for transparency reports. And finally, the model-based approach supports other languages. We can consume or produce models in TypeScript and Python in the same way like we do it in Java. So we can have a UI-based EMF. And all in all these components are OSGi based and use the OSGi architecture model. Use all the dynamics, modularity, and it works well for models as well, not only for runtime applications. For us, EMF and OSGi is a perfect team. It's our stack. We work with it for years now. We can use it for IoT on embedded devices as well. And we say we use end-to-end modeling and instancing in the end. Yeah. A model-based platform like this is a toolkit for dynamic distributed modular components. They can act as over an existing infrastructure as a transparent layer. So, thank you very much. Are there any questions? Yeah.
It looks like you got a relatively centralized architecture with the mobile app as a single point. One thing from my experience, there's always a huge resistance from parties that are not under the same management to collaborate through this. They want to offer something and they want to use something, but they don't really want to be subservient to a central thing. How do you handle that? Because
it's not really a central thing, it's a central point of contact. It's not a central, there's no need that you have a central component. You can have many model atlas instances in your infrastructure with different configuration, or you can have one instance in the
model in EMF to be able to collaborate. They'll say, well, we got JSON schema, figured it out.
Yeah, you can create JSON schema out of an
but they
EMF.
have JSON schema, they standardize. And I'm being a little bit devil's advocate, but that's what I saw in practice is that you try to create a really good intermediate format where everybody can standardize on and live with. And the first time they find another tool that has a tiny little feature extra, they are disloyal.
Usually we don't really have a problem with that because EMF itself you can derive JSON schema from that, and you can go the other way around. You lose some functionality because JSON schema is not as powerful, so rather you use XSD and stuff like that. So this is basically what in the end, everything they give us will end up being EMF, but we kind of we can read a lot of formats in there.
Especially when we talk about smart city models, there are a lot of XSDs or RDFs out there that are definitions for smart models in general. And we create echo out of that because in return we can also create a RDF or the XSD again. And so from that point of view, we are fine. Because the point is that eCore, UML, contains more information about the whole world. It can define special references, which is not possible in XSD. JSON schema is a definition how to write JSON and not how to define a model. And this is the major difference. And the same applies to XSD. So we know the problem, but usually we try to teach the people.
It's not a technical problem.
This is indeed. And we try to teach the people to see that they have to create their own models, and they should not depend on a certain presentation format like JSON or XML. So, but it's difficult to learn because it's a little bit meta. So.
The good thing is a lot of the tools that are around, which you can comfortably do modeling with, speak Ecor at the end. So you can usually get that right out of Magic Draw or whatever.
Yeah.
So name the UML tool of your liking.
And you could hide this layer from the management. You can show them your eyes and say, okay, here put your JSON schema in, or here put your 5 examples of a JSON in, and we create it from this.
Yeah, and sometimes they want to deal with JSON. Management don't want to deal with JSON, and from that point of view, we are fine because we're defining models. And for those who want to deal with JSON, we are also fine. This is, but it's still hard sometimes.
Yeah,
Because
I
it's
can see that.
yeah. Other questions?
Do you use it in, is it running productively in some cities?
Yeah, in the city of Jena.
Yeah, okay.
Yeah,
Soon to be more.
yeah, we're working on it.
For me, it's a bit interesting because from my side, it's not depends on the smart cities. It's a use case for everyone
Yeah.
who says, I want to have data and I want to be sure that the types are correct. And I know that in the next 10 years, I will get tons of new models and I want to easily integrate it and don't have to write
Yeah.
code for each new model. So it's an abstraction layer on top of modeling.
Yeah, I needed a buzzword.
It's used a lot for the smart city world because the restriction of creating GDPR documentation is very high and it must all be
It's a big sell, I guess.
like this in the system. For this, this was the main purpose of starting with EMF because you always get what is in the system.